Hello everyone, I wanted to make a quick video on parents, children, and inheritance inside of Godot. Um, these concepts at the beginning are going to apply to all programming languages, and then as we get deeper into the video, we'll switch over to Godot and GDScript and see how you can actually use this concept in something you might be making right now. So, the idea behind parents, children, and inheritance is we need a way to manage many objects that are going to have many similarities. So the best example of this that I could think of is a car in video games. And a car is a great example because if you think of like GTA or any game where you have cars and driving, you're going to have like hundreds of different cars that are all going to function almost exactly the same. They're going to have the same mechanics, all that sorts of stuff. So you're not going to want to like repeatedly go over and over again and make a new one each time. So how would you go about programming that? Well, if you don't want to repeat yourself, the first thing you might think of doing is to copy and paste the car. So let's do that really quick and see how that works out for us. So let's make a copy of the car over on the left, and we'll make another copy of the car over on the right. And we'll make these cars slightly different because why would you just copy something and make it exactly the same? So we'll make this car red, and we'll make the car in the back fast. We'll give it racing stripes. Here we go. So, what's the problem here? Nothing right now. Everything will work just fine until you have to go in and make a change. So let's say that down the line you find out that your acceleration and your deceleration isn't working how you want it to. You want to like decelerate slower on mud, accelerate slower on mud. You're going to have to go into each and every single one of these scripts that you made for each and every one of these cars because you copy and pasted it. You're going to have to fix the error that you made in each one of these scripts. And that's going to take forever. Bugs are going to crop up that you're not going to be able to find, you're not going to be able to manage, and it's just going to be a pain in the butt. And especially if you have more than 3 of whatever object it is, it's going to be even more difficult. So, let's go back, let's delete what we did, and instead of just copying it and pasting each of these cars, what we're going to do is we're going to make this car the parent, and we're going to make these cars children of that parent. So they're going to be linked together in code with this top car being the parent whose code is inherited by the children. So let's take a look at how that would be different. And let's change our cars like we did before. This will be a red car. Middle car will now be our fast car. And then our back car is going to have little tinted windows, and that will be its difference. So now we come across the same problem that we had before, where we want to implement a new feature. The deceleration and acceleration is going to be different on different surfaces. Instead of having to go into each of these scripts and make the change, what you'll do instead is just go into the main parent script, make the change there, and each of these cars down here will inherit the change that was made to the parent car. So that's the basic concept, is having one place to make changes where all the children are going to inherit those changes, and that way you can keep track of bugs and keep track of all your code much more easily. It's much more manageable. So let's go into Godot and see how we can actually use this in our project and how we can actually implement this. Let's get started. All right, so we are in Godot, and you do not have to follow along. The more important thing is that you understand what's going on. But if you are following along, the only thing I've done is I've made a 2D node. I've called it game, and I've saved that 2D node so I can run it up here. You can select your current scene, or you can use the other play button. And I have a couple labels for our demonstration here. So let's go ahead and make a floor real quick out of a static body 2D. We'll add a collision shape to the floor because it needs that. Make the collision shape a rectangle. Bring all of that down to the floor area. And then we'll resize the collision shape to actually fit across the floor here. There we go, that should work. And then we will make our items that we're going to use for our parent and child relationship. So our items are going to be rigid bodies. They are going to need a collision shape. Collision shape is going to need a shape once again. And we're just going to represent these rigid bodies with a colored rectangle. That's going to be what represents our item here. And we'll rename the rigid body to item parent. All right. So let's go up here real quick because that is where it is. And we'll resize the collision shape to actually fit. And that should work. And then we'll bring the parent down. Actually, before we bring it down to the floor real quick, let's save it. We'll right click and we'll save the branch as a scene, and item parent will work. And then we'll drag it down. That should prevent it from spawning way down here when we go to do a step later. So all we did so far was we made an object. It could be anything. We happened to make something called an item, and we saved it as a scene. So that's the first step. We have to save something as a scene. Then we go down here to the scene, and we'll right click it, and we'll do a new inherited scene. Now remember, a child inherits from a parent. So by creating a new inherited scene, we're making a child real quick. So new inherited scene, a new tab's going to pop up. It's going to seem like we're in the parent because that's what it's called, but we can actually see we're in an unsaved tab. We are in a new object. So let's rename that let's rename the object to item child, and we'll save it really quick. Item child.tsn is fine. So now in those two steps, by making a scene and then making a new inherited scene, we have a parent and a child. And I actually have 2 slots for childs over here. So while we're doing this really quick, we'll make a second child by doing the same thing, new inherited scene. And we're going to save this as item child 2. So item child 2.tsn. All right, so let's bring those bad boys out here. Child number 1 on the left and child number 2 on the right. So we basically set up parent and child relationship so far. Like, it's already set up. This is how you would do it. Let's see how it works. Let's see how each thing is affected. So the first thing, let's change the color of everything. Let's change the color of the parent square and both the children squares. So to do that, we would go down here and we would open our item parent scene. And we can see that our parent scene over here has the items that we put in it at the start. One quick note is you can tell if something's inherited in the editor by if it's yellow. If it's yellow, it's an inherited thing. If it's white, it's like not inherited. It's the default. So let's change the color of all of our cubes to, say, purple. And let's hide our collision shape on all of our cubes. So because we made the change in the parent, it's going to propagate down to both of the children. So let's see that really quick. By going over to the game, we can see that all of our cubes are purple without a collision shape. I don't know what that blue is, but in addition, I didn't do this before, but we can see if we run our scene, all the cubes fall to the ground. So fine and dandy, fine and dandy. I actually move this one down so that we can see that they all fall at the exact same speed. Boom, boom, boom. All right. So let's take this a step further. When we're doing parents and children, the idea is we can make small changes to the child and they don't affect the parent. The parent changes affect the child, but not the other way around. So let's make a change to this child over here, and we'll see that nothing happens anywhere else in the project. So we go to item child number 1, we go to its color rectangle, and we will switch it to blue. And we will save, and we will see in the game scene, our one child is blue, everything else is purple. Now, because we've done that, we've made the default color of the child, or we've changed the child number 1's color from its default color to another color. So it's no longer linked to the parent. We can see that it's different from the parent. So if we make a change to the parent's color now, It's not going to affect the child. We'll see that child number 1 remains the same, while the parent, child number 2, will change. So let's see that in action. Go over to parent number 1, go to its color rectangle. We are going to change it to yellow this time, yellowish, orangish, sort of. So in our game, our parent and our child number 2 are both the yellow-orange, and our child number 1 is still blue, because its color is not the default color. It's got its own color, so that's what it's working off of. But if we go and we go back and now we change child number 1's color back to its default color, child number 1, this sets the property back to default, this little back arrow if you didn't know that. Boom, it's orange. It's orange now because that's the default color of the parent. Like, that's what the parent's color is. So now all the child's colors, their default color is that orange. So go back to the game after saving the child, see that it changes. If you notice your changes aren't happening in real time, that's probably because you aren't saving as you're moving back and forth in between tabs. I'm hitting Control S really quick as I tab back and forth to make all the changes. So, coming back to it, let's summarize really quick. You have a parent whose changes will propagate down to the children, unless the children has that value already specified, in which case the child will use value that's specified for it and it will ignore the parent value. But it still knows that if you revert the value back to the default value, it should use that parent value. All right, so I think we understand how the relationships work within the editor. Let's bring it into code because it's a little different. It's a little bit confusing, but if we understand everything that's going on here, it'll all make sense. So first things first, in order to do anything with code, we need a script. So let's go to the item parent and let's add a script really quick. So right click, attach script. And item parent is fine and click create. The only thing that we need to do to make a parent class script is to use the keyword class name and then to give it a class name. So we're calling our item our class item, so we'll give it the class name item. And then we'll also go down and we'll really quickly define its ready function. And for right now, we won't put anything in it. We'll just put pass. That is fine. So what have we just done here? We've made a object, a class in the editor called item that can be used elsewhere in the editor. But because we attach the script to the item parent, we'll see over here, both of our children have inherited that script. And we know why, because of the stuff we discussed earlier. We made a change to the parent and it propagated down to the children. There's one problem with this though. We don't want the parent script on the children. We want the children to have an inherited script, because if we were to have the parent script on the children, we wouldn't be able to make changes on the children. And the whole point of parent and child relationships, change the child, it doesn't affect the parent. Change the parent, it does affect the child. So, first thing we're going to want to do, we'll detach the script and we'll detach it from both of these really quick. I'll show you a shortcut at the end of the video so you can avoid this, but for now we'll do it the manual way because it's the more intuitive way. So, then we'll right click, we will attach a script and we'll call it itemchild.gd, that is fine, and we'll do the same for the other child. Actually, no, we won't attach a script to the other child. We will leave the other child without a script. So, let's make those saves. Now, in the child script, in order to actually make it a child script, because right now this is just a script. It's attached to a child object, but it's not a child script itself. It's just a script. So to make it a child script, we take this extends keyword that's already written out for us. And instead of extending a rigid body, what we're doing is we're extending an item. All you need to do, and now you have the parent and child relationship set up within the script. So kind of like the previous part, we have it set up like it functions, but how do we use it practically now, right? Over in the parent script, I made a ready function, and right now it doesn't do anything. So what we're going to do is we're going to make some properties, which are just going to be variables. We're going to make a property called gravity. We're going to give it a default value of 1. And we're going to make a property called color. We're going to give it a default value of red. Down here in the ready function, we're going to call modulate, and we're going to set it equal to color. And we're also going to do gravity scale. And we're going to set the gravity scale equal to gravity. So what have we done here? Well, go into the game real quick. We'll notice actually before we run anything that the scripts did not attach to the child object in the editor, if that makes sense. So we attach the script to the child over here in the actual child object scene that we have, but Godot did not attach the script to the object in the editor, which is a little confusing. I don't know why it does that, if that's on me or if that's on them. But all we have to do is we will add the item child script to the item child. So we'll have a parent with the parent script. We'll have a child with the child script. And we'll have a child with no script. So let's think about this for a moment. Let's think about how this all works before we even run it. We have a parent script that goes in and it sets the modulate, which is just a fancy word for the color. It sets the color to the color property that we made earlier, which is red. It sets the gravity scale, self-explanatory, to the gravity that we set up here. Right now it's at default. 1.0 is the default gravity. Then, when a child spawns, the child has a script that extends the parent script. So this child script, even though it's totally blank, is going to run all the code that's in here. It's going to get these variables, it's going to make them into properties, and it's going to have this function, and it's going to run. So what we're going to see here is, going back to this scene, right now in the editor they're orange, because this is script stuff. It's going to happen at runtime. When we run the script, the parent, the child number 1, and I'm pretty sure the child number 2 as well, are all going to change to red, and they should all fall at the same speed. They fall at the same speed regardless right now, but the main thing is they should all change to red. So let's see that happen. Child number 2 didn't change to red, and I kind of wondered if that would happen because child number 2 doesn't have any script at all, so it's not running anything at runtime. So we could have predicted that, but I'm bad at coding, so I did not predict it in time. But regardless, we have the parent and the child script over here. And so let's actually use the parent and child script. Let's go to the parent script, or excuse me, let's go to the child script and let's change something, because that's the whole point, is we want to be able to change the child. So let's override the ready function. We'll make a new ready function. So what we're basically saying is, don't run the code in the parent function at all. And we can see that because this is running no code and this is running no code, and they're both orange. So we've overridden the ready function. Actually, instead of overriding it though, let's set some properties in here. So we'll set the gravity property to be really, really low. And we'll set the color property to be a different color. So we'll say color is now color dot Alice blue, whatever that is. But if we run it, we'll notice that it doesn't actually do what we want it to do. It still looks like it's running no code. It sets these properties, but what it's not doing is it's not running the ready function from the parent. To fix that, we use the keyword /key function super. What super does is it looks for this function inside its parent class. So because super is called within ready, it looks for a ready function within the parent class. And then it calls all the code that's inside of the ready function. So in order, what this function is going to do, it's going to set the gravity property, it's going to set the color property, and then it's going to do super, which takes us over to parent, calls this line of code, which sets the color, and calls this line of code, which sets the gravity. Now, one last thing before I run this. It's important to note, we did not have to set any of these variables. Like, because they're declared in our parent function, gravity and color are just ready for us when they're not typically ready for us. So, let's run the code, and we'll see child number 1 falls slowly. It doesn't get set to blue for some reason. So it turned out the problem was with the color I picked, apparently. Because I switched the color to green, and it does exactly what I expected it to do. Changes the far left cube child number 1, which has the child script attached to it, to green. And yeah, changes the gravity as well. So let's bring it all back around. All together now. Let's go over to our game scene so we can visualize it real quick. We have a parent, a child number 1, and child number 2. When we change properties of the parent, if they're not set on the child, then they get changed on the child as well. However, we can change properties of our child without affecting the parent and without affecting other children. And we can enhance this by using scripts. When we make a script and we want it to be a parent script, we use the class name keyword and we give it a class name. Then when we use child scripts, we extend that class name to make it a child. Now, I told you that there would be a little tiny trick I would show you to kind of make it so you didn't have to make a whole bunch of different scripts for a whole bunch of different children. And that is this section right here. So this is kind of taking it even a step further. So what we're going to do is we're going to go and we're going to detach all of the scripts from all of the stuffs. And instead of having all of these different scripts, we are going to just have the parent script, but we're not going to attach it to anything. We're just going to attach the child script. And we're going to make a little adjustment to the parent script. These variables are now going to be export variables. And then the last thing is, instead of hard coding these variables, we will just have the ready function ready to be overwritten, but right now it's not going to really be overwritten because it's going to call the super function instead. So what this is going to do, it's going to propagate the child script down to the children if we make new children. We've been editing these children, so we have to re-add the child script to them. But we will see, if we were to create a new inherited scene from our parent, it's over here. The process is now way easier. We can call this item child 3 is how I've been naming them. And we will see that the variables that we set are actually now available in the editor over here. We can change them around. And the child script, we can make changes to it. The only issue with this setup is that anything that has to change from child to child is going to need to be some sort of export variable or something along those lines. And if you need unique functionality, you would either extend again into another child class, or you would just make a one-off class that covers that specific case where you need differing code. So again, that last part doesn't make a lot of sense. Don't worry about it. It's more important that you understand the overall concepts that were presented in the beginning part of the video. And then if you watch it again and this last part clicks like, oh, I can shortcut by using the skill, I can use parents and children to make parents and children easier. then that's when you know you've really got it. If you've gotten to this part and it all clicks, then you know you've really gotten it. If not, go back and watch the paint part, because the paint is the more important concepts that you need to know. So, sorry that this was a little bit long-winded. It's a little bit more of a difficult concept, and I kind of do a free-form style with these tutorials. This is the first tutorial I'm doing. I plan to do one on variables, a really, really deep, like half an hour dive into variables. Hopefully people will be interested in that. Plan to do the same thing with scope. So if you don't know what scope is, it's super important in programming, super important in Godot and GDScript. So I plan to do a deep dive into that. Make sure you like, you subscribe, you tell me in the comments like what I could improve, what you'd want to see, ideas for video and all that stuff. And like, I know a lot of people say like and subscribe at the end of the videos, and I'm sure they mean it, but like with me, if you don't like and subscribe, I probably won't be able to keep making videos. This is my very first tutorial that's going up, so it's really important, you know. So that being said, I'm bad at coding. If you made it this far, thank you very much. I hope you understand parents and children and their relationships. Thank you again. See ya.